Hi everyone, how are you doing? Our lesson today is simplifying square root expressions. In this lesson, we will learn to simplify the square root expressions and rationalize the denominator. First, let's know what's mean like radicals. Sometimes there are square root expressions involving square roots with the same radicands, like this. Square root 3 to square root 3. They are called like radicand. Like radicals. It's like terms. When we have x and 3x, like terms. These like radicals. 2 square root 5 and 4 square root 5 like radicals. 6 square root x and 2 square root x means the same expression or the same number inside the square root. We called it like radicals. Now if we have we have 2 and square root 15. Are they like radicals? 2 is constant and square root 15. 2 is natural number and square root 15. They are unlike radicals. If we have 6 square root x and square root 6x. Are they like radicals? Here we have x inside the square and here we have 6x. Not same means they are unlike radicals. And if we have 3 square root 2 and square root 3, also unlike radicals. Now let's get some practice simplifying radical expressions that involves variables. So let's say I have 2 square root x plus 3 square root x. To simplify this expression, let's first add these numbers. 2 plus 3. 2 plus 3. And here we have like radicals. We keep it. 2 plus 3 is 5. So it's 5 square root x. So like radicals can be combined by adding or subtract. Just when we have like radicals, we can simplify the expression. If we have like this, 3 square root x plus 2 square root 3x, we can't combine the radicals. Just when we have like radicals. Let's take more examples. Here we have add 3 square root of 7 plus 8 square root 7. Square root 7, here we have square root 7 like radicals. So we need just to add 3 with 8 is 11 and we keep square root 7. Here we want to subtract 9 square root y minus 3 square root y. We need to subtract 9 minus 3, and we keep the square root. 9 minus 3 is 6, so it's 6 square root y equals 6 square root of y. We want to simplify this expression. Negative 8 square root 3d plus 6 square root 2d plus 10 square root 3d. 10 square root 3d with negative 8 square root 3d like radicals. So we can combine negative 8 plus 10 equals 2, and we keep square root 3d. There is no like radicals with square root 2d, so we put it plus square root 2d. We can simplify more. Here we have 3d and here we have 2d. So this is simplest form. Now we have this example. Simplify each expression. 3 square root 8 minus square root 45. Square root of 8 and square root of 45. They are unlike radicals, so we can't combine them. But don't forget, sometimes radicals do not appear to be like until they are simplified. So we need to simplify these radicals and then we see if they are like radical or unlike radicals. Square root 8, we can write it as square root 4 by 2. So it will be 3 square root 4 times 2 minus square root 45. We write it as 2 by 5. We can write 45 also 3 by 15. But we take 9 by 5 because 9 is perfect square. Here the square of 4 is 2. So it will multiply by this number here. It will be 6, and 2 is not perfect square. We put it inside the square. Minus 9 times 5. 9 is perfect square, so the square root of 9 is 3. And 5 is not perfect. It stays inside the square root. So it's equal 6 square root 2 minus 3 square root 5. Also we get unlike radicals, so we can simplify more. This is simplest expression. Now we have this example, square root 125 d plus 3 square root 20 d minus square root 45 d. 125, we can write it as 25 by 5d plus 3 square root 20, we can write it as 4 by 5d minus 45, also it's 9 by 5d. 25 out of the square, it will be 5. We keep 5d inside the square. Plus 4 out of the square, it will be 2. We multiply it by this number, it will be 6 square root 5d minus 9 out of the square is 3 square root 5d. Here we get all 5d inside the square, means we have like radicals here, so we can combine. It will be 5 plus 6 minus 3. 5 plus 6 minus 3 square root 5d. 5 plus 6, 11, minus 3 is 8 square root 5d. Look, we simplify this fraction to 8 square root 5d. Now we want to learn how to multiply square roots. We have square root, it's like multiplying algebraic expression. Here we have square root 3 by square root 3 minus square root 5. We will use distributive property. Square root 3 by square root 3, then square root 3 by square root 5. Square root 3 by square root 3, it's square root 9, minus square root 3 by square root 5, it's square root 15. We multiply the numbers inside the square roots. We will put it inside one square, so it will be square root 15. Square root 9 is a 3. 9 is perfect square, so it will be 3 square root 15. 15 is not perfect square, and we can't write it as a multiply of perfect square and another number. We just 3 by 5. So 3 is not perfect, 5 also is not perfect. So we will put it square root 15. This is simplest expression. Now we have this example. 4 plus square root 5. 3 minus square root 5. Expression by expression. So we need to multiply each number and each square root by all terms in the other expression. First, 4 by 3 is 12. Then 4 by negative square root 5, it's negative 4 square root 5. Here means we have 1. It's like algebraic expression. When we have x, it's mean 1x. Here you have square root 5, it's mean 1 square root 5. So 4 by 1, it's 4 square root 5. Now we need to multiply square root 5 by the other expression. Square root 5 by 3, positive by positive. It's positive 3 square root 5. And then square root 5 by negative square root 5, it's negative square root 25. When we multiply two square roots, we multiply the numbers inside the square. 5 by 5, 25. Here we have 12, and here we have negative 4 square root 5 plus 3 square root 5, like radicals, so we can combine. And here we have negative square root 25. Square root 25, it's mean 5. I will write 5. So we get 12 minus 5, it's 7. And negative 4 square root 5 plus 3 square root 5. The sign of the greatest is negative. 4 minus 3, different signs, so we subtract. It's 1 square root 5. It means 7 minus square root 5. 1 square root 5 or square root 5, it's same. Now we have another example. Here we have square root 7 minus 5 all to the power 2. You know, when we have power 2, it's mean like this, x power 2, it's mean x by x. So here we have this expression power 2, it's mean the expression by the expression. Square root 7 minus 5 by square root 7 minus 5. Also, we will use the distributive property. Square root 7 by square root 7, it will be square root 49. You can write it 7. Square root 49 is 7, so you can write it 7. Now square root 7 by negative 5, it's negative 5 square root 7. We will multiply negative 5 now. Negative 5 by square root 7, it's negative 5 square root 7. Negative 5 by negative 5, it's positive 25. Let's recombine the like term. Here we have like terms, or like radicals. And 7 plus 25. 7 plus 25 numbers, we can combine them. It's 32. And negative 5, it's mean negative 10 square root 7. Now we have this example. Square root 7 over square root 2. We want to simplify this quotient. Square root 7 over square root 2. 2 is not perfect square and 7 also. So how we can simplify this expression? Students, sometimes the denominator in algebraic expression involving square root. Here the denominator square root 2. When we have like this expression, the denominator, it has square root. We need to multiply the numerator and denominator by this square root, like this. Here we will multiply by square root 2 over square root 2. This mean 1. You know, when we have same expression, numerator and denominator, it's mean 1. So the value of this expression, it stays same. But why we put this? Because we want the denominator without square root. Here we will get square root 7 by square root 2. It will be square root 14 over square root 2 by square root 2. It's square root 4. And square root 4 is 2. We will get perfect square of perfect square. So we will get 2. We can write it without square root. So I multiply by the square root 2 over square root 2 to make the denominator without square root. Always when you see the denominator with square root, you should multiply by this square root to make it without square root. This is called rationalizing denominator. Okay, let's retake another example. Here we want to simplify this expression. 1 plus square root 3 over 2 square root 3. Look here, we don't have any perfect square and we can combine one with square root 3. So we need to write the square root, the expression, sorry, without square root in the denominator. What should we do? We need to multiply by square root 3, because here we have square root 3 in the denominator, over square root 3. Here we have two terms, so it's expression. We need this to distributive. Square root 3 by 1, or 1 by square root 3. It will be square root 3. Square root 3 by square root 3, it's plus square root 9. Square root 9, it's mean 3. I told you when you have square root 3 by square root 3, you can write it directly just 3. Or square root 5 by square root 5. When you have same number inside the square root, you can write it just this number without square root. It will be over 2 square root 3 by square root 3, also it's square root 9, it's mean 3, so 2 by 3. It will be square root 3 plus 3 over 6. Look, we remove the square root sample from the denominator. This is called rationalizing denominator. Thank you for watching.